What if I told you that our galaxy is hiding a secret city of stars so massive, so crowded, and so mysterious that even the most powerful telescopes of the past were completely blind to it? But the James Webb Space Telescope has finally opened the door. This hidden world is called Sagittarius B2, a colossal cloud of gas and dust sitting just 27,000 light-years away, close to the supermassive black hole at the center of the Milky Way. For decades, astronomers stared at this region, knowing it must be special. But the dust was too thick, the gas too heavy. It was like trying to see a lighthouse through a wall of stone. No light escaped until the arrival of the James Webb Space Telescope. Before we continue with this discovery, please subscribe and like the video. It helps the algorithm reach more people who are fascinated by space discoveries. So what James Webb Space Telescope found shocked everyone. Inside Sagittarius B2, Webb uncovered two different populations of massive stars, one that we could see before and another completely hidden, buried deep in the cloud. It spotted radiation blasting out through strange tunnels, carved by young stars like secret escape routes of energy. And most puzzling of all, it revealed a perfectly sharp boundary, a straight edge slicing across the cloud as if someone had drawn a line in space. Why does this matter? Because Sagittarius B2 is not just a cloud, it is a cosmic nursery, one of the most powerful star-forming factories in the Milky Way. And now, for the first time in history, we can finally look inside. Think about it. When you see Sagittarius B2, you are not just looking at a star cloud, you are looking at the past of our universe. Because conditions here may be the same as those that existed in the first galaxies billions of years ago. To understand the mystery, we must first ask, what is Sagittarius B2? At first glance, it looks like a giant dark cloud near the center of the Milky Way. But this cloud is not empty. It is stuffed with raw material for star formation, hydrogen, helium, and dust grains. How big is it? Sagittarius B2 is about 150 light-years wide. That's big enough to swallow our entire solar system millions of times over. It is one of the most massive molecular clouds in our galaxy, weighing nearly 3 million times the mass of our Sun. But what makes it truly fascinating is its location. It lies in the central molecular zone, a region just a few hundred light-years from Sagittarius A2, the supermassive black hole at the heart of the Milky Way. That means Sagittarius B2 is living in one of the harshest cosmic neighborhoods you can imagine. Radiation, gravity, and magnetic fields here are far more intense than in quiet regions like our solar system. So why do astronomers call it a stellar nursery? Because inside this chaotic cloud, stars are being born in huge numbers. Massive stars, some dozens of times heavier than our Sun, ignite and blast radiation across space. Smaller stars form in clusters, hidden in cocoons of gas. But here's the catch. For decades, telescopes could only see the surface of this giant cloud. The dense dust blocked almost all visible light, hiding the true scale of star formation. It was like trying to study a city by only looking at its glowing rooftops. And this is where the James Webb Space Telescope changed everything. Its infrared eyes pierced through the dust and gas, revealing not just the rooftops, but the entire hidden city of stars inside Sagittarius B2. And what Webb saw inside was stranger than anyone expected. When James Webb opened its golden mirrors towards Sagittarius B2, astronomers expected to see stars, but they didn't expect two hidden worlds. The first was familiar. A population of stars we could already detect from Earth or older telescopes. These were the brighter, less obscured stars near the outer layers of the cloud. But behind them, Webb uncovered a second population, a group of massive stars completely buried in dust. These were invisible before, hidden so deeply that only Webb's infrared vision could bring them into view. Think about that for a moment. For decades, astronomers thought they knew the story of this cloud. But now Webb is showing us a parallel hidden universe, where some of the most powerful stars are living and dying without us ever knowing. And the surprises didn't stop there. Inside Sagittarius B2, Webb also detected something strange: radiation escaping through tunnels. Picture this: a newborn star, buried in a cocoon of gas, usually traps its light. But in Sagittarius B2, Webb found that the light isn't completely trapped. Instead, Young stars carve out channels, cosmic escape routes, where energy blasts out into space. It's as if the stars are punching holes through the cloud, creating glowing corridors of radiation. This tells astronomers something crucial. Even in the densest clouds, star formation can reshape its environment, letting energy leak out and affect the surrounding galaxy. But perhaps the strangest thing Webb found was a cosmic razor's edge. On the eastern side of Sagittarius B2, the cloud doesn't just fade out like mist, it ends in a sharp, straight boundary. A line so precise it looks almost artificial. Why would a natural gas cloud have such a clean edge? Was it shaped by external forces like shock waves or magnetic fields? Or is something else at work in the heart of our galaxy? The mystery deepens. Because Webb didn't just find stars, it found clues that the universe is hiding more secrets than we imagined. So why does all of this matter? Why should we care about hidden stars, escape tunnels of radiation, or a mysterious sharp edge in a distant cloud? Because Sagittarius B2 is not just a random star factory, it is a time machine. The extreme conditions inside this cloud, dense gas, violent radiation, and powerful gravity, are very similar to what the early universe looked like billions of years ago. That means by studying Sagittarius B2 today, we get a window into the birth of the very first stars that ever lit up the cosmos. Here's the fascinating part. When the first galaxies formed, their environments were messy and chaotic, just like Sagittarius B2. If Webb can decode the secrets of this one nearby cloud, we might finally understand how the earliest stars were born and how they shaped the universe we see today. But there's more. Webb's discovery of hidden star populations means that our galaxy might be forming far more stars than we thought. Astronomers may have been underestimating the true power of star formation in the Milky Way for years. And those radiation escape tunnels? They're not just pretty details. They may explain how stars are able to influence their surroundings, clearing out gas, shaping new stars, and even changing the life cycle of entire galaxies. But the biggest puzzle remains that sharp boundary. Nature doesn't usually draw straight lines. So why is Sagittarius B2 sliced so neatly on one side? Some astronomers suggest it could be the result of shock waves, perhaps from older supernova or other powerful events in the galactic center. Others think it might be shaped by magnetic fields, bending the cloud into a strange structure. But here's the truth. Nobody knows for sure. And that uncertainty is what makes this discovery so thrilling. Every new answer Webb gives us seems to open up two new mysteries. The question now is simple. If Sagittarius B2 hides this many secrets, what else is our galaxy still hiding in the dark? The deeper we look into Sagittarius B2, the stranger the story becomes. It feels less like a simple gas cloud, and more like a cosmic crime scene, where every clue leads to a bigger mystery. Let's lay out the evidence. Hidden stars buried in dust. Why are so many massive stars cloaked so deeply? Are they forming differently here than in other parts of the galaxy? Escape tunnels of radiation. Who carved them? Are they signs of violent young stars fighting their way out? Or is some other force shaping these corridors? A sharp, straight edge. Nature almost never creates such clean boundaries. Was this edge sculpted by an outside shockwave? Or is it the fingerprint of something even stranger, lurking near the galactic center? Each clue makes one thing clear. Sagittarius B2 refuses to play by the rules. And that's why astronomers are so fascinated. Because if the rules don't apply here, maybe they didn't apply in the early universe either. Imagine galaxies billions of years ago forming their first stars. Imagine star factories like Sagittarius B2 scattered across the young cosmos. If they behaved like this cloud, with hidden stars, chaotic radiation leaks, and mysterious edges, then the early universe might have been far more violent and unpredictable than we ever imagined. But here's the twist. Every time scientists solve one puzzle about Sagittarius B2, another appears. For example, if hidden stars are so common here, could other star-forming regions across the Milky Way also be hiding entire stellar populations? If radiation can escape through tunnels, could this explain how galaxies in the early universe became so bright, so quickly? And if sharp boundaries exist in one cloud, how many more might be camouflaged across the galaxy? The truth is, Sagittarius B2 is not just giving us answers, it's forcing us to rewrite the questions we ask about star formation, galaxies, and the universe itself. And that's why this discovery is not the end of the story, it's the beginning of a much bigger one. Now that the James Webb Space Telescope has peeled back the layers of Sagittarius B2, astronomers are left with a challenge. How do we decode the secrets it revealed? The data Webb collected is enormous. Hundreds of images across different infrared filters, each one exposing a different layer of the cloud, from the glowing gas to the hidden stars buried inside. But here's the exciting part. Scientists believe this is just the first glimpse. With more observations, Webb could track how these hidden stars evolve over time. It could map the radiation tunnels in greater detail, showing how young stars carve their escape routes, and it might even explain the mystery of the sharp edge, giving us a clue about whether it's shaped by shock waves, magnetic fields, or something entirely unknown. But why stop there? Astronomers are already planning to use Webb's results as a template. If Sagittarius B2 behaves like this, maybe other giant molecular clouds across the Milky Way, or even in distant galaxies, are hiding similar secrets. That means every hidden star Webb uncovers could help rewrite the story of star formation across the entire universe. And let's not forget the bigger picture. The central molecular zone, where Sagittarius B2 lives, is a chaotic region near the supermassive black hole, Sagittarius AI. This is one of the most extreme environments in our galaxy. If stars can thrive here against such violent conditions, it changes how we think about where life could begin in the universe. But here's the haunting thought. If this one cloud can hide so many secrets, what else is concealed in the shadows of our galaxy? Could there be other hidden nurseries bursting with stars we've never seen? Could entire stellar populations be invisible, waiting for Webb to uncover them? One thing is certain, Sagittarius B2 has opened a door, and once a door like this is opened, there's no going back. The story of Sagittarius B2 is not just about one cloud, it's about the destiny of our galaxy. You see, the Milky Way has been building stars for more than 13 billion years, but not all regions are equal. Some parts of the galaxy are calm, forming stars at a steady pace. Others, like Sagittarius B2, are wild, chaotic, and incredibly productive. Think of it this way. If the Milky Way is a city, then Sagittarius B2 is its industrial district, working day and night to produce new stars. By studying this cloud, astronomers can measure how star formation fuels the growth of the galaxy. They can also trace how massive stars, the giants hidden inside, will eventually explode as supernovae, enriching the galaxy with heavy elements that form new planets, and maybe even life. But there's another layer to this story. Sagittarius B2 doesn't just influence the galaxy's future, it reflects its past. Billions of years ago in the early universe, conditions were harsher, denser, and more unstable than they are today. Star factories back then might have looked almost identical to Sagittarius B2. That means when we look at this cloud, we're not just studying the present, we are looking at a living fossil, a cosmic laboratory that tells us how the first stars might have been born. And here's where the mystery deepens. If Sagittarius B2 is a mirror of the past, what does it say about the future? Could the hidden stars inside become the next generation of supernovae, reshaping the galaxy with shockwaves? Could the escape tunnels of radiation trigger new waves of starbirth in neighboring clouds? And could the sharp edge be a sign that forces near the galactic center, maybe even the pull of Sagittarius A, the supermassive black hole, are sculpting clouds in ways we don't yet understand? Every answer we uncover in Sagittarius B2 ripples outward, rewriting our vision of the Milky Way's grand story. This is no longer just one cloud, this is the heartbeat of a galaxy. As we step back from Sagittarius B2, it's impossible not to feel awe. A single cloud, hidden in the heart of the Milky Way, holds secrets that challenge everything we thought we knew about stars, galaxies, and the universe itself. The James Webb Space Telescope has done more than just take pictures. It has unveiled a hidden world. Stars buried deep in dust, invisible to every telescope before. Radiation tunnels carved by young stars, blasting energy into space. And a mysterious sharp edge, defying our expectations of how clouds form. Every new discovery raises new questions. Every hidden star we find suggests there may be countless others waiting to be seen, and every strange structure reminds us that the universe is far more complex, strange, and beautiful than we can imagine. But why does this matter to us, here on Earth? Because the story of Sagittarius B2 is the story of our cosmic origins. These stars, forming in extreme conditions near the galaxy's center, are clues to the first stars in the universe. By studying them, we learn how galaxies grow, how planets form, and perhaps even how life itself becomes possible. It's a reminder that the universe is alive with mysteries, and that every new telescope, every new observation is like opening a door to a room we didn't even know existed. And the truth is, Sagittarius B2 is just the beginning. If this one cloud holds such astonishing secrets, imagine what the rest of the Milky Way or even distant galaxies might be hiding. So the next time you look up at the night sky, remember this. Beyond the stars we see, beyond the dark patches of dust, there are hidden worlds, stellar nurseries, and cosmic puzzles waiting for us to discover. And thanks to the James Webb Space Telescope, humanity is finally beginning to peek behind the curtain. Because in the end, the universe is not just something we observe, it's something we are part of. And every mystery we uncover, every hidden star we reveal, brings us one step closer to understanding our place among the stars. If you could explore any hidden part of our galaxy, which mystery would you want to uncover first? Hidden stars, cosmic tunnels, or the secrets near the supermassive black hole? Let me know your thoughts in the comments below. I'd love to read them. And if you enjoyed this journey into Sagittarius B2 and want to uncover more cosmic mysteries, don't forget to like this video, subscribe to the channel, and hit the notification bell so you never miss our next space adventure. Remember, the universe is full of secrets, and together, we're just getting started.